Thank you for watching this channel. This channel provides easy to understand and excellent books in Japan in English, and provides useful information for practical equipment design.
This time we will explain about design method of the local exhaust. We use the Japanese book that Factory Ventilation Theory and Practice. So, what is the local exhaust? This method is the most effective means for dealing with pollutant sources and is frequently used. 1. Prevents the spread of contaminants generated. 2. Aspirates, captures, and discharges near the source. The hood is intended to capture and pick up the pollutants produced, and its sucking distribution must have sufficient exhaust air capacity to draw the pollutants produced. We would like to introduce the kind of hood first. We can classify the two types of hood for local exhaust. First, enclosed hood. Its all contaminant sources are enclosed inside the hood. It can be minimize the volume of exhaust when reduce the wind speed at open area. However, if reduce open area, it will be reduced workability too. Inside hood is considered as polluted area. Therefore it should be plain that the work must be done outside the hood. Second, external hood. It's included canopy hood, side intake hood, and so on. Its contaminant sources outside the hood opening and capture contaminants away from the opening. Due to the distance from the opening, the required wind speed, capture velocity, increases with increasing distance from the opening. External hoods should be placed as close to the source as possible. If this is difficult, consider additional control of contaminants, such as a push-pull ventilation system. We will proceed with the explanation about method of design about exhaust hood. There is two types of condition we should consider. 1. The pollution is not match-generated condition. 2. Consider generated pollution. So, we will explain about not match-generated condition first. 1. We will decide the control or capture velocity. Please see the table 3:1. There is the condition of contaminant sources. Based on the conditions, we can select control or capture velocity. Next 2. In case of enclosed hood, we can use this simple formula. Just multiply area of opening and control velocity. Next, in case of external hood, we can use this empirical formula. X is the distance from edge of contaminate to hood opening. As per this formula, if add the flange, required volume to be reduced. This is because the airflow on one side can be suppressed by attaching a flange. You can see from this formula that attaching a flange is a simple and effective measure. Table 3-5 is a summary of the discussion so far. There is the formula and condition for each type of hood. When you proceed with the design, you may use this table as quick reference. Then, we will explain the design method when the generating condition. First, we make understanding about the exhaust volume as per formula. Q3 is total exhaust volume. Q3 consists from Q1 and Q2, where Q1 is the amount of pollutants generated, and Q2 is the air volume to capture so that the pollution does not spread. And then, we will consider the safety factor. N is the safety factor for leaking contaminate. KL is the flow ratio when start leaking. So if we will select N and KL, we can calculate required exhaust volume. How to select KL. Please see this table 3 to 5. This the summary of type of exhaust. There is the formula to calculate KL based on the conditions. Next sheet also same table. Different type of exhaust hood. So we can select KL value from this. Next we will select safety factor N. It can be select from table 3 to 7. It was depend on the ambient air velocity. So we can select safety factor N also. Then we can complete local exhaust design. At first glance, local exhaust is determined by empirical rules. However, when introducing local exhaust ventilation, the working environment for workers is often poor. From the viewpoint of engineering ethics, it is important to understand these empirical formulas and perform confirmation calculations so as not to harm the health of workers and to design without failure.
Thank you very much and see you next movies.